Welcome to aminacademy.com. In Laplace transform, let us do some example problem by using initial value theorem. Look at this example. By using initial value theorem, find Laplace transform of cos at and Laplace transform of sin at. Now, let us take the first one. Laplace transform of cos at. Let f of t equal cos at. Then you can say f dash of t equal minus a sin at. Also f dash of 2t equal minus a square, because there is a square here, cos of at. Now by using initial value theorem, Laplace transform of f dash of t equal a square into Laplace transform of f of t minus s into f of 0 minus f dash of 0. Here Laplace transform of f2 dash of t, that is Laplace transform of f2 dash of equal minus as f2 dash of t is minus a square cos at equal a square into Laplace transform of f of t minus s into f of 0. Suppose the function f of t equal to cos at, if put 0, cos 0 is first write here is f of 0 minus f dash of 0. Here we know f dash of 0, first f of 0 is cos 0 is 1, and f dash of 0, f dash of is minus 80, that is 0, a into sin 0 is 0, and therefore we are using the initial values here. Then we can write therefore we can say minus a square L of Laplace minus a square Laplace transform of cos of at equal a square Laplace transform of f of it equal to here a square into Laplace transform of cos at minus here f of 0 is 1, that is minus s, and f dash of 0 is 0, that is minus 0. So we can say this one, write one more time, a square into Laplace transform of cos of at equal a square into Laplace transform of cos at minus s. Here both side we are having Laplace transform of the same function, that is right here, which is replacing here, that is a square Laplace transform of cos at plus a square Laplace transform of cos at equal s. From that collecting cos of here a square plus a square into Laplace transform of cos at equal s. Therefore, Laplace transform of cos at equal s over a square plus a square. Now, let us do. So, we got the result already. We got previous videos. We got Laplace transform of cos at in another way. So, we got the same result here. Next, we have to find the Laplace transform of sin at. Sin of at we are finding. Here, let f of t equal sin at, and then you can say f dash of t equal sin t differentiation is a cos at. Here, now we have Laplace transform of f dash of t equal SL by initial value function SL, initial value theorem is SL into f of t minus f of 0. Now we will apply here. Therefore, Laplace transform of f dash of t is my a cos at equal s into Laplace transform of sin of at minus f of 0. Here a into, we know Laplace transform of cos at equal s into s square plus a square, we got 2s, then it is equal s into Laplace transform of sin at, right as it is, then f of 0 here, f of t equal to sin at, if you put t 0, sin 0 is 0. This f of 0 is 0 here. Therefore we can say Laplace transform of sin at equal a s over a square into a square, then s come down, s cut both sides. Therefore we can say Laplace transform of sin of at equal a over a square plus a square. We got the results. We have done. Please subscribe our YouTube channel.